Dear students, through coming problem, we are going to learn the application of the Gauss theorem. So let us move to the question part. In this question, it is given a system consists of a ball of radius capital R carrying a spherically symmetric charge, and the surrounding space is filled with a charge of volume density rho equal to alpha divided by small r, where alpha is a constant and small r is the distance from the center of the ball. We need to find the charge in the ball, for which the magnitude of the electric field strength vector is independent of r outside the ball, and also we need to calculate the electric field strength. Okay, and the permittivity of the ball and surrounding space is assumed to be unity. This is the question. Now let us analyze the situation. What is happening? Suppose this is a ball and total charge in the ball is capital Q and radius is capital R. This is the surrounding space whose charge density is varying according to a relation rho equal to alpha divided by small r. And it is given the magnitude of the electric field strength vector is independent of r. So let us assume a point at a distance small r from the center of the ball. This is the point. And at this point, the electric field intensity is independent of r. It is given. That means we need to find the electric field intensity at this point. For finding the electric field intensity, we need to apply the Gauss theorem. And we know the Gauss theorem is the closed surface integral E dot ds equal to Q enclosed divided by epsilon naught. Okay, that means we need to draw the Gaussian surface passing through this point. And we know charge is having the spherical symmetrical distribution, and here the charge distribution is changing according to this relation. That means the Gaussian surface passing through this point under consideration should be spherical. And if you observe here in this Gauss theorem, in the left hand side we have E dot ds. If the Gaussian surface is spherical, that means the left hand side should be equal to E multiplied by 4 pi r square, because electric field vector and area vector on the Gaussian surface always will be parallel to each other, and electric field magnitude will be uniform in the sphere. So left hand side part should be equal to E multiplied by 4 pi r square. And in the right hand side part, you can observe this is Q enclosed. Q enclosed include the charge in the ball capital Q and charge enclosed between capital R to small r. So first of all, we need to calculate charge between this region. For this purpose, let us draw a sphere of radius small r and then further dr thickness spherical cell like this. So let us draw dr thickness spherical cell. The charge enclosed in this region from r to r plus dr should be equal to 4 pi r square multiplied by r, because 4 pi r square is the surface area of the sphere of radius small r and thickness is dr. That means the volume of the charge should be equal to 4 pi r square multiplied by dr. Okay, charge density is alpha divided by r. That means charge enclosed in this region should be equal to 4 pi r square dr multiplied by alpha divided by small r. So charge enclosed can be written as this capital Q plus integral from capital R to small r, and this is 4 pi r square dr multiplied by alpha divided by r like this. You can observe here this small r and this small r will get cancelled. So we can write this expression like this. Okay, this is again small r square and r will get cancelled. So this is the final expression. And we know the integration of this term is r square by 2. So we can write like this. Now we can put the limit. This is small r square by 2 minus capital R square by 2 can be taken outside the bracket. We can further solve like this. This is the electric field at this position. So let us write this electric field expression to the next page. This is the expression, final expression. Now let us do one thing. Let us open this bracket like this. Okay. Now it is given electric field is independent of small r. If it is independent of small r, that means this term is having a small r relation, this term is also having a small r relation. That means the subtraction of these two terms should be 0. That means this relation Q divided by 4 pi epsilon naught R square is equal to alpha R square divided by 2 epsilon naught small r square, like this. Okay. Now we can calculate the value of capital Q. It is equal to 2 pi alpha R square. So this is the value of the charge inside the ball. Now these two terms will get cancelled. That means the electric field at the point under consideration should be equal to alpha divided by 2 pi epsilon naught. So this is the value of the electric field. Okay. Dear aspirants, Cengage India has launched the new edition of our JEE Advanced Physics books. Please visit www.cengage.co.in to buy a copy. You can also buy the books from Amazon or Flipkart.